In December 2020, a team of environmental chemists at the University of Washington published a paper in one of the most prestigious scientific journals on Earth, the journal Science. What they found shook the automotive and environmental world to its core. For more than 2 decades, entire populations of Coho salmon had been dying in mysterious, massive waves every time they returned to urban streams in the Pacific Northwest to spawn. Nobody could explain it. Wildlife agencies tested the water for pesticides, heavy metals, industrial runoff. Nothing matched. And then, Zhenyu Tian and his colleagues finally cracked the case. The killer was not a factory. It was not a farm. It was a chemical called 6-ppd quinone, a toxic byproduct that forms when a common tire rubber additive reacts with ozone in the atmosphere. The same compound that is sitting on the sidewalls of your tires right now. That discovery changed everything we thought we knew about tire chemistry. And it opened a door to an older question, one that the modern automotive industry has almost no financial incentive to answer. Is there a simpler, safer, cheaper way to protect the rubber on your tires? The answer has been hiding in plain sight for over 200 years. Today, we are going to trace that answer from an 18th century Swedish laboratory, through the rubber plantations of colonial South America, across World War II battlefields, and into the garages of Japanese car enthusiasts who have been quietly using it for decades. This is the story of vegetable glycerin, a substance so cheap, so effective, and so stubbornly unpatentable that no corporation on Earth has ever had a reason to tell you about it. The chemical that started it all. To understand why glycerin matters for your tires, you first need to understand the silent war that is being waged against every piece of rubber you own. Rubber, in its natural form, is one of the most remarkable materials humans have ever discovered. When French explorer Charles Marie de la Condamine traveled through South America in the 1730s and 1740s, he encountered indigenous peoples who had been using the milky sap of the Hevea brasiliensis tree for centuries, to waterproof clothing, to make bouncing balls, to seal containers. The material was elastic, waterproof, and endlessly moldable. But it had one devastating weakness. Heat turned it into a sticky, foul-smelling mess. Cold made it crack and shatter like glass. That problem haunted inventors for nearly a century. European entrepreneurs went wild over rubber in the early 1800s. Factories opened, rubber-coated raincoats hit the market, investors poured money in. And then summer came. Warehouses full of rubber goods melted into foul-smelling, sticky heaps. The investors fled. The factories collapsed. Rubber looked like a dead-end material. And then along came Charles Goodyear, a man so obsessed with fixing rubber that he spent years experimenting in his kitchen, went bankrupt, and was thrown into debtor's prison multiple times. His own family nearly starved. But in 1839, at the Eagle India Rubber Company in Woburn, Massachusetts, Goodyear accidentally dropped a mixture of rubber, sulfur, and white lead onto a hot stove. Instead of melting into the usual putrid goo, the rubber charred evenly, like leather. It stayed flexible in the cold. It held its shape in the heat. Goodyear had discovered vulcanization, the chemical process of cross-linking rubber polymer chains with sulfur bridges, and he had unlocked the modern rubber industry. It took him 5 more years of painstaking experimentation to perfect the process, and he finally received his patent in 1844. Tires, gaskets, hoses, seals, conveyor belts, shoe soles, industrial machinery, all of it flows from that accidental moment on that Massachusetts stove. And tragically, Goodyear himself never profited. He died in 1860, $200,000 in debt. The company that bears his name, Goodyear Tire and Rubber, was founded 38 years after his death by men who never met him. They simply used his name because it had become synonymous with rubber itself. But vulcanization solved only half the problem. It made rubber strong and temperature stable. It did not make rubber immortal. And the enemy that vulcanized rubber could not defeat was already in the air, invisible, odorless, and relentless. The invisible enemy. Every single day, the rubber on your tires is under attack from an enemy you cannot see, smell, or feel. That enemy is ozone, a molecule made of 3 oxygen atoms that exists in trace amounts in the air all around us. Ground-level ozone is generated by sunlight reacting with vehicle exhaust and industrial emissions. Even in clean air, concentrations of 5 to 10 parts per billion are normal. Near highways and parking lots, it can be significantly higher. Here is what ozone does to rubber. Every molecule of natural and synthetic rubber used in tires, polyisoprene, polybutadiene, styrene-butadiene rubber, contains carbon-carbon double bonds in its polymer backbone. These double bonds are what give rubber its elasticity, its stretch, its ability to absorb shock. And ozone attacks those double bonds directly. In a chemical reaction called ozonolysis, the ozone molecule cleaves the double bond, severing the polymer chain. One chain becomes 2 shorter chains. Then those shorter chains get attacked. Then those fragments get attacked. Over months and years, this invisible molecular warfare turns supple, resilient rubber into a dry, brittle, cracked shell of its former self. This is what the industry calls dry rot. And it is not just cosmetic. Cracked sidewalls compromise the structural integrity of the tire. They reduce its ability to absorb road impact. In extreme cases, they can lead to catastrophic blowout failures at highway speed. The tire industry knows about ozone degradation, of course. Their solution is to add anti-ozonant chemicals during the manufacturing process. The most widely used of these is a compound called 6-PPD, N-open parenthesis 1,3-dimethylbutyl close parenthesis dash N prime dash phenyl dash P dash phenylenediamine. It works by migrating slowly from the interior of the rubber to the surface, where it reacts with ozone before the ozone can reach the polymer chains. Think of it as a chemical bodyguard that sacrifices itself to protect the rubber beneath. The problem is that when 6-PPD reacts with ozone, it produces a transformation product, 6-PPD quinone. And that is the exact molecule that Zhen Tian's team identified as the Coho salmon killer. The lethal concentration is astonishingly low, just 95 nanograms per liter of water for adult coho, and as little as 41 nanograms per liter for juveniles. To put that in perspective, 1 nanogram is 1/1000th of a gram. A single teaspoon of 6 ppd quinone dissolved in an Olympic swimming pool would be enough to reach lethal concentrations. The mechanism is devastating. Rainfall washes 6 ppd quinone off tire wear particles on roads and highways, carries it into storm drains, and flushes it directly into the streams and rivers where salmon return to spawn. In urban areas of the Pacific Northwest, researchers have measured 6 ppd quinone concentrations in stormwater runoff up to 2.4 micrograms per liter, more than 25 times the lethal dose for Coho. During heavy rain events, entire stretches of salmon-bearing urban streams become death traps. The affected fish gasp, lose equilibrium, swim erratically, and die within hours. The toxicity is unusually species-specific. Coho salmon are devastatingly vulnerable, while closely related species like sockeye salmon and chum salmon appear largely unaffected, a puzzle that researchers are still working to understand. Brook trout and rainbow trout show intermediate sensitivity, but the environmental implications are profound and growing. The global rubber industry is now actively seeking alternatives to 6 ppd, but no replacement has yet been found that matches its effectiveness as a tire anti-ozonant. So here is the situation. The modern tire industry's primary defense against ozone cracking is a chemical that protects your rubber but generates a byproduct that poisons aquatic ecosystems when it washes off the road. And what does the aftermarket tire care industry offer you on top of that? Petroleum-based tire dressings, silicone sprays, products that coat the surface in a temporary glossy film, a film that does nothing to condition the rubber itself, that attracts dust and road grime within days, and that needs to be reapplied constantly to maintain the appearance of protection. This is where the economics get interesting, and this is where glycerin enters the story. The sweet principle of fat. In 1779, a Swedish chemist named Carl Wilhelm Scheele, the same scientist who independently identified oxygen, chlorine, barium, and manganese, was conducting an experiment involving olive oil heated with lead oxide. What dripped out of that reaction was a colorless, odorless, viscous, faintly sweet liquid that Scheele had never seen before. He called it the sweet principle of fat. Decades later, French chemist Michel-Eugène Chevreul gave it the name we use today, glycerin, from the Greek word glykis, meaning sweet. Glycerin, or glycerol, as chemists call it, is a simple molecule. 3 carbon atoms, each bonded to a hydroxyl group. It is a trihydric alcohol. It is non-toxic, biodegradable, and approved for human consumption by the FDA. You have eaten it in marshmallows, chewing gum, and cake icing. You have rubbed it on your skin in lotions and moisturizers. It is one of the most widely used ingredients in pharmaceuticals, cosmetics, and food processing on the planet. Glycerin was even a critical precursor in the manufacture of nitroglycerin, the explosive that Alfred Nobel tamed into dynamite in 1867, transforming the construction and mining industries forever. The same humble substance that keeps your birthday cake moist helped blast the tunnels that carry your morning commute. But here is what matters for your tires. Glycerin is a humectant, one of the most powerful humectants known to chemistry. A humectant is a substance that attracts and retains moisture from the surrounding environment. When glycerin is applied to a polymer surface like rubber, it does not just sit on top like a silicone spray. Its small molecular size allows it to penetrate into the surface layer of the rubber matrix, where its 3 hydroxyl groups form hydrogen bonds with water molecules, effectively trapping moisture within the rubber and maintaining the flexibility that ozone and UV radiation are constantly trying to destroy. In simple terms, it does for rubber what a good moisturizer does for your skin. It does not just coat the surface, it actually hydrates the material from within. This property has been known for a very long time. Experienced mechanics and rubber workers have used glycerin to maintain rubber seals, O-rings, gaskets, and hoses for generations. The forum archives of automotive enthusiast communities are full of old-timers recommending glycerin as a seal conditioner going back decades. Before the explosion of commercial rubber dressing products in the 1980s and 1990s, glycerin was simply what knowledgeable people used to keep rubber in good condition. So why has this not become mainstream? The economics of forgetting. Here is the uncomfortable truth that no one in the tire care industry will tell you. Not because it is a secret, but because no one profits from telling you. Vegetable glycerin cannot be patented. It is a naturally occurring compound that has been in the public domain since the 18th century. You cannot put a proprietary formula around it. You cannot build a brand moat with it. You cannot charge a premium for it. A 16-ounce bottle of pharmaceutical-grade vegetable glycerin costs between $3 and $5 at any pharmacy or online retailer. And that single bottle will make enough tire dressing to last an entire year. Compare that to the commercial tire dressing market. A quality bottle of Tire Shine runs $8 to $15 and lasts for perhaps a dozen applications. Professional tire dressing services at detailing shops charge $20 to $40 per visit. Multiply that across the estimated 290 million registered vehicles in the United States alone, and the tire aftercare market represents billions of dollars in annual consumer spending, built almost entirely on products that coat the surface of the rubber in temporary films rather than conditioning the rubber itself. Now ask yourself this: if you were a product executive at a tire care company, would you fund research into a substance that costs your customers $3 a year? Would you allocate marketing budget to promote a product that eliminates the need for repeat purchases? Would you put a product on the shelf that cannibalizes every other product on that same shelf? No corporation has an incentive to fund research on glycerin as a tire conditioner. No marketing department has a budget to promote a product that costs pennies per application and cannot be branded. No tire shop is going to recommend a solution that eliminates the need for repeat visits. This is not a conspiracy. No one sat in a boardroom and decided to suppress glycerin. The mechanism is far simpler and far more powerful than that. When a product cannot generate recurring revenue, cannot be patented, and cannot support a marketing budget, it simply fades from public awareness. Not through suppression, but through economic indifference. The knowledge does not disappear. It just stops being promoted. And within a generation, what was once common shop wisdom becomes forgotten lore. This pattern repeats across dozens of industries and hundreds of products. The most useful solutions are often the ones with the smallest profit margins. And that is why you have never seen a television commercial for vegetable glycerin tire dressing. How to make it, the actual recipe. The formula is almost absurdly simple. You will need 3 things. A clean spray bottle. 500 milliliters is a good size. A bottle of vegetable glycerin. Make sure it is 100% vegetable glycerin, food grade or pharmaceutical grade, with no additives. And distilled water. Not tap water, because the minerals in tap water can leave residue on the rubber. Mix 1 part glycerin to 4 parts distilled water. That means if you measure out 100 milliliters of glycerin, you add 400 milliliters of distilled water. That gives you a 20% glycerin concentration, which is the sweet spot. Concentrated enough to condition the rubber, dilute enough to spread evenly and absorb without leaving a heavy, greasy film. Add 2 to 3 drops of regular dish soap to the mixture. This tiny amount of surfactant breaks the surface tension of the water, allowing the glycerin solution to spread evenly across the hydrophobic rubber surface instead of beading up and running off. Shake the bottle gently to mix. Before you apply anything, clean your tires thoroughly. Use a stiff bristled brush and an all-purpose cleaner or dedicated tire cleaner. Scrub the entire sidewall until all the brown oxidation residue, road grime, and old product buildup is removed. Rinse completely and let the tire dry. This step is not optional. Glycerin needs a clean surface to penetrate effectively. If you apply it over old silicone or petroleum residue, it will not bond properly and you will be disappointed with the results. Once the tire is clean and dry, spray the glycerin solution onto a clean foam applicator pad, not directly onto the tire. Then, wipe the solution evenly across the entire sidewall in overlapping circular motions. You want a thin, uniform coat. Do not flood the rubber. More is not better. 1 thin, even application is all you need. Let it sit for 10 to 15 minutes. The glycerin will absorb into the surface layer of the rubber. Then take a clean, dry microfiber cloth and gently buff off any excess. What you should see is a clean, dark, natural-looking satin finish, not the artificial mirror shine gloss of a silicone spray, but the deep, rich black of healthy, well-conditioned rubber. What to expect and what to be honest about. Now, here is where intellectual honesty matters. If this video told you that glycerin makes your tires shine for years without any maintenance, as the title provocatively suggests, that would be misleading, and this channel does not do misleading. Here is what glycerin actually does and what it does not do. What it does. It conditions the rubber surface by maintaining moisture content. It restores a natural, satin-dark appearance to oxidized sidewalls. It is completely non-toxic, biodegradable, and safe for the environment. No 6 ppd quinone washing into waterways, no petroleum solvents leaching into soil. It costs literally pennies per application. And as a humectant, it genuinely supports the long-term flexibility of the rubber surface it is applied to. What it does not do. Glycerin is water-soluble. It will wash off faster than silicone-based products when exposed to rain and road spray. Most users report that a single application maintains its visible effect for a few days to about a week under normal driving conditions, not weeks or months. It does not provide UV protection the way some commercial products with added UV blockers do. It cannot reverse structural damage from deep dry rot or sidewall cracks that have already penetrated below the surface. And it is absolutely not a substitute for replacing tires that are worn, damaged, or past their service life. If your tire sidewalls show deep, branching cracks, or if the tread is worn to the wear indicators, no surface treatment of any kind, commercial or homemade, is going to fix that. Replace those tires. Your safety is not something to gamble with. One more thing to be aware of. Because glycerin is water-soluble, it performs best in dry climates or during dry seasons. If you live somewhere with frequent rain, you may need to reapply after every significant rainfall. In wet climates, some users combine their glycerin routine with the periodic application of a quality water-based commercial dressing that includes UV protection, using the glycerin as a regular conditioner between less frequent applications of the commercial product. This hybrid approach gives you the conditioning benefits of glycerin at minimal cost, while adding the UV and weather resistance of a commercial formulation when needed. The value of glycerin is not that it is a magic potion that replaces all commercial products forever. The value is that it is an incredibly cheap, safe, and effective maintenance tool that you can apply regularly, weekly if you want, at almost no cost, conditioning the rubber surface consistently over time, rather than coating it in periodic layers of silicone or petroleum. Think of it this way. Commercial tire dressings are like foundation makeup. They cover the surface and make it look good temporarily. Glycerin is like a daily moisturizer. It is not flashy, but used consistently, it maintains the health of what is underneath. And for the environmentally conscious among you, the fact that you can maintain your tires without sending 6 ppd quinone runoff or petroleum-based chemicals into the nearest storm drain is not a small thing. That is a meaningful choice. The bigger picture, why this matters beyond tires. The glycerin story is ultimately not really about tires at all. It is about a pattern that shows up everywhere in modern consumer life. The pattern of useful, simple, unpatentable solutions being displaced not by better solutions, but by more profitable ones. Consider the history. When Carl Wilhelm Scheele discovered glycerin in 1779, he had no idea it would become one of the most versatile chemical compounds in human civilization. He was just a curious chemist, heating olive oil with lead oxide to see what would happen. When Charles Goodyear dropped rubber and sulfur on a hot stove in 1839, he was a bankrupt inventor, one experiment away from giving up. When Zhenyu Tian's team at the University of Washington identified 6 ppd quinone in 2020, they were trying to solve a salmon die-off mystery that had baffled wildlife agencies for 20 years. None of these discoveries came from corporate R&D departments chasing quarterly revenue targets. They came from curiosity, persistence, and the willingness to look at familiar problems from unfamiliar angles. The tire care industry is not unique in this pattern. The cleaning product industry sells you dozens of specialized sprays when white vinegar and baking soda handle most household cleaning tasks. The skincare industry charges premium prices for moisturizers whose primary active ingredient is often glycerin itself, the same compound you can buy in pure form for a fraction of the price. The lawn care industry sells complex chemical treatments when compost and proper mowing technique solve most problems. None of these industries are evil. None of them are running conspiracies. They are doing exactly what market economics incentivize them to do, selling products with margins that justify marketing budgets, shelf space, and distribution networks. The problem is not malice. The problem is that the incentive structure of consumer markets naturally suppresses the promotion of solutions that cannot generate sufficient profit to pay for their own advertising. The result is a world full of expensive, branded versions of things that already exist in cheaper, simpler, unbranded forms, if only you know where to look. The antidote to this is not anger or cynicism. The antidote is education. When you understand the chemistry of why rubber degrades, you can evaluate tire care products on their actual mechanisms rather than their marketing claims. When you understand the economics of why glycerin is never promoted, you stop waiting for corporations to tell you about solutions that do not serve their business model. This is what Oracle Prime has always been about. Not conspiracy theories, not grievance, not fear. Just real knowledge, real chemistry, real history, and the practical skills to make better decisions for your home, your vehicle, and your wallet. A small bottle of vegetable glycerin, a spray bottle, some distilled water. That is all that stands between you and a tire care routine that costs almost nothing, harms nothing, and works with the chemistry of rubber rather than against it. The knowledge was never hidden. It was just never profitable enough for anyone to sell it to you. Now you have it anyway, and that is the real power, not the glycerin, but the understanding behind it. Take that understanding and use it, not just on your tires, but everywhere. Question the products you buy. Learn the chemistry behind the claims. Look for the simple solution that nobody is advertising, because that is often exactly the one that works.